So we're the UNL Biological Systems Engineering team. We were sponsored by UNL AMI Swine Lab, and this is our presentation. So to start off, a little bit about our project. We were working on improving a current system that ran in MATLAB that was concerned with monitoring pigs so that we can get their data. We want the data to make sure that we can monitor their health. For example, if a pig is sick, we want to be able to provide that information to the caretakers so that they're aware that they can tend to the needs. On the other hand, maybe the pigs are doing healthy and ready for marketing soon. So we also want to make sure we have that data. We do this primarily through the use of RFID technology. Each pig has an RFID tag, and then when they go to eat or feed, drink, that's monitored by a sensor, and then from there we have our data that we have collected. It'll check the date that the pig has been monitored feeding or drinking, the frequency, how long they're there, stuff like that. And that helps us know, for example, if a pig hasn't been eating for a while, that needs to be tended to. So overall, another important piece of this program was a camera that is used. It's tagged when a pig is determined to be at a feeder, and based off of that image, we can get some data as well. So we want to make sure we're getting our images and collecting our data. I'll pass it off to Kwan now to introduce some of the people involved in this project.
Thank you, Adam. So before we go deep into our project, we want to say special thank you for our sponsor, Professor Tammy, and then Raj. Without them, we cannot make it until the end. And then we also have a faculty, staff, and coach, Vinod, and then Nick. Thank you for being here and then support us until the end. And then your idea very supportive, and then Melanie is not here, but she always help us to manage our Gen Hub and then working with the scheduler team. And I'm going to pass to Adam to talk about the problem and opportunity. And then introduce about our team. We had the development manager, Morgan, product manager, Adam. Developer, we have Hunter, me, Ailey. She not here. She just quit after the first semester. But her contribution in the GUI design is very expensive. And then we have Dudley as developer. And the next slide going to be about the problem and the opportunity. Adam going to have to talk about it.
Thanks, Kwa. So as I mentioned, part of the problem and opportunity with this system is there already was an existing one in place that our sponsors has been using. There were some inefficiencies to it. For example, it was run in MATLAB, designed there. Some other inefficiencies where it was currently run on Windows OS, which came with a few problems, such as the program shutting down, needing to restart. It wasn't as reliable as it could be. And we wanted it to run smoother to make sure that we could get as much data out of the system as possible. Because when, for example, if the Windows needs to restart and the program stops, we lose important data, and we want to be making sure we can get all of that. So to optimize the system, we wanted to make the MATLAB program that's shown to the right, we wanted to make that into Python. We wanted to make a reliable data transfer form for the server so that the data we're getting locally, we can make sure we have that on our server. We wanted to give a small hardware footprint, making sure the Windows and OS, we can find a better solution for that, as well as using minimal user interaction. So if something stops working, we don't have to send somebody out to go fix it. And then again, change that Windows OS. So our solution for each of these problems was, instead of using Windows OS, we wanted to use Linux machines using Ubuntu 18.04. We use Ubuntu 18.04 because it works with the current camera that is in use in the system. That's the Azure Connect Microsoft camera. And we did this to kind of address the smaller hardware footprint and unreliable system issue. We also used a Python program instead of the current MATLAB image capture system program. And then we introduced a native Linux operations, which is a software suite called systemd that was basically used for restarting the program if it stops. If it shuts down, it'll pop it right back up again. So that helps with keeping this running. We have a picture on the bottom left of the Azure Connect Microsoft camera, and to the right is Bionic Beaver, which is Ubuntu 18.04. And then we also introduced several new APIs to make sure that we can reliably get the data from the local up to the server so that we can actually have all of our data in one place. And then below I listed some of the types of data that we were using. So some of the values and highlights, I think this is a project with a lot to learn from. Personally, I think the API solution, there's a lot to learn there. Integrating something new and modern to an already existing system. For example, with a camera that's a little bit older than some of the new high-tech stuff that us in academia might be a little used to. Keeping some of the old features, yet incorporating new techniques so it's familiar to people who are already maintaining the system. And this program is unique. It's one of a kind, so there's no set standards. So modifying an architecture that is truly unique was also interesting. We learned about value gain to the project that we added was some fault management and error handling with sending our local data to the system. We wanted to give it a more robust communications protocol. A lot of the fault handling helped us do that, and then making sure we got our data. Another thing that I thought was very important was learning about sponsor communication. Working closely with them was very helpful, working on a project that already existed. There was a lot of moving parts, such as the APIs, the system, the ICS program that had to do with the capturing, making sure the system could reboot if it died, and then making sure that we were all on the same page, making sure we were using the same jargon, stuff like that. I think it was really important that we were able to work with this, and I think we learned a lot through it, making sure that we were able to really be able to deliver a product that met the needs. Quad, do you want to talk about something that you've learned too?
Thank you, Adam. So for the ICS side, that we learned that we know how to program the Python in the professional environment, and then how to deal with the multi-threading, and then TCP as well. This is very completely new with us, but we know how to do it, and then do it in the professional way, and then how to pass it to the another team. And then the value that we gain after this is we able to read the data from tag and then transfer the data to the reader, so the reader can change the data to the server. And then another thing is we try to make the connection becomes more stable, and then if it turn off, and then we can able to turn it on in a short time. And then last but not least, Adam gonna talk about the thank you and then conclusions.
So to end off the project, I think that it was a great experience to work with a team, to work with sponsors, to be able to work on an existing project, since a lot of time, especially in industry, that's what you're going to be doing. You're not going to be working on something off the bat. So I think there's a lot of invaluable lessons to learn there. And finally, I want to give a thank you to the people that helped us make this project work. I'd like to thank our product manager, Mel. She's not here with us, but she was very helpful. I want to thank Nate, who was our coach. He was extremely helpful all along the way. He was a huge help in getting us to have some of the more reliable communications protocols work. Thank you for that. I want to thank Vinod too. He's our tribe lead. And then finally, I would also like to thank Raj, who was a humongous help making sure that we knew what was going on. He is a mastermind behind the current system. And so he was able to inform us on design decisions, how the system should be working, what we wanted to work on. Something that I've talked about is the fault management, and he was especially helpful there, making sure that we knew some cases that we should handle to make sure that we can make sure our data is safe. So thank you, everyone, for all of your hard work on this project.